It's time to simplify using these lovely identities. The key here is knowing your identities, ladies and gentlemen. You will not get a cheat sheet of them on your quizzes or your tests. You just have to know them. And unfortunately, taking notes is rather kind of silly because there are oftentimes there's so many different ways to do these proofs, to do these simplifications. But there is also often one very obvious or easiest answer. So I'm going to try to walk you through a few simplifications, remind you of how to factor, and then as the week progresses, I will do some of these proofs for you and show you how it is done, but ultimately the ball is in your court. You have to learn how to play this game. I cannot hold your hand and tell you exactly what approach to take. You just have to try it. If it doesn't work, try something else. If it doesn't work, try again. If you get frustrated, take a break. It's okay. Buy yourself a big fat eraser. Using pen on this section will cause you heartache and pain. Okay, so just don't do it. Pick up a pencil. That's what they're for, right? Math class. Okay, so in the first one, you may have an idea, you may want to jump right in and do something, or you may be sitting here scratching your head. And again, I can't really tell you exactly what to do. Just go with your gut, go with your instinct. This is your fourth, and for some of you, like your fifth or sixth math class. What do you notice? You notice you have two things, a minus sign in the middle. You notice that they have a like term in them. Ooh, it's time to do the F word, folks. Let's factor, right? Okay. Let's pull out that sign of x. Why? Why not? Let's see what it gets us. I mean, it may not work, but let's try it. If I factor a sine x out, the first part is left with cosine squared x, and then I just have minus 1. Well, that's interesting, right? Maybe not. Maybe. Ooh, wait a second. This right here. That looks very similar to one of the Pythagorean identities. In fact, it is a Pythagorean identity, just rewritten. What is cosine squared x minus 1? You got it. It's sine squared. So I can substitute right like that. What about the rest of it? Bring it down for now, right? Oh, wait a second. What is sine of x times sine squared of x? Well, that gives me a total of 3 of them, right? So I guess the final answer is just sine cubed of x. And we are done. We have simplified a mess to turn it into a single term. Perfect. Let's look at number 4. Secant theta over cosecant theta. Now, some of you are brilliant enough that you think in terms of secants and cosecants. That's wonderful. Most people do not. Most students are only comfortable talking about sines and cosines and maybe tangents because that is just sine theta divided by cosine theta. So I'm going to try this. I'm going to take this guy right here and rewrite it. I'm going to rewrite secant as 1 over cosine theta. Okay. Then I'm going to take cosecant theta and rewrite it as 1 over sine theta. It may have looked like I've made this worse than it really is, but hold on a second before you throw in the towel and start getting irritated. Let's break this up. Instead of having it as one giant complex fraction, let's think of it as 1 over cosine theta, times, let's flip that bottom fraction. Let's write that one as sine theta over 1. Okay, well, I can multiply straight across the top, multiply straight across the bottom, right? So that gives me sine theta divided by cosine theta. Here we go again, ladies and gentlemen. That is one of our identities, tangent of theta. Boom. Simplified. Pretty cool, huh? All right? I know. Okay, so number 5 looks worse than 3 and 4. 3, you probably saw the like factor immediately. 4, you had the instinct to rewrite stuff. 5, you look at it and you're like, gee, I don't know about this one. Well, whenever you're in doubt or when you don't see an obvious place to start, just go ahead and rewrite everything into sines and cosines. It might not work. Again, I cannot tell you for certain that that is going to be the number one way to make it happen. But you can't go wrong. If you screw it up, just start over. What is cosecant? 1 over sine theta. Oh, excuse me, this time we're using x. Minus cosine. Well, you can't really rewrite cosine, right? So it's just cosine of x. And it's being multiplied with cotangent. Cotangent is cosine x over sine x. And you could say, well, I can put these two little pieces here together, right? So I can leave this as 1 over sine x. I'll get to that in a minute. It looks rough there. Minus cosine squared x, because cosine x times cosine x is cosine squared, all over sine x. Hey, I am taking two fractions and subtracting them. They have like denominators, so I can go ahead and just put them together, right? So the numerators combine to be 1 minus cosine squared of x. And the denominators are the same, sine of x. Here we go again, ladies and gentlemen. What do we know about this right here? 1 minus cosine squared x is a Pythagorean identity. It is equal to sine squared x. And I still have my denominator of sine of x. Let me put an equals there if you want to. And what happens now? I simplify it up. Sine squared x divided by sine x is equal to sine x over 1, which is just sine of x. And the last one I'm going to work out for you is number 6. Don't forget about the beta, folks. Alpha, beta, theta, x, y. It's just a variable. Just a letter. Don't hate on letters. 1 plus cotangent squared beta. Wait a second. Here we go again. I'm pretty sure that is a Pythagorean identity. Sure enough, cosecant squared. So on top I still have my cosecant of beta. On the bottom, that is actually equal to cosecant squared of beta. Cosecant beta divided by cosecant squared beta leaves me with 1 over cosecant beta. And you may think that that is simplified enough, but again, think about it, folks. Cosecant in and of itself is kind of a reciprocal to begin with, so 1 over the cosecant of beta, you really should just write this as plain old regular sine of beta. So if you don't think this is fun yet, don't worry. You get like the rest of the week into next week to practice. I'm going to pause the video for just a second and push it up and show you the last piece of this one. Alrighty, this last section is really just here to remind you of how to factor, or perhaps teach you if you never learned in the first place. Take a look at number 7. Difference of squares, ladies and gentlemen. That's all this is. Just write this as the quantity of cosine x plus 1 times the quantity cosine x minus 1. Second one, again, think of this as the variable. I have like x squared minus 4x minus 12. I do not have a leading coefficient other than 1, of course, so I can just break this down into my two parentheses. How do I break down sine squared of x? I have sine of x times sine of x. What two numbers multiply to give me a negative 12, but at the same time those two values will add to give me a negative 4. Sounds to me like 6 and 2. I've got a minus 6, a plus 2, and I have factored. Last one. Secant squared x minus tangent x minus 3. Okay, the first thing you're probably thinking is you're panicking and going, oh my gosh, these aren't the same trig function. What do I do? There's no way. Of course there is. You know your Pythagorean identities. Secant squared. What is secant squared? Sorry about that. What is secant squared x? Oh, that's the same thing as 1 plus tangent squared x, right? So you can make a substitution here first. You can say that's 1 plus tangent squared x. And then we still have our minus tangent x minus 3. Clean this up a little bit, and you have tangent squared x minus tangent x minus 2. If you think of this as x squared minus x minus 2, you can solve it no problem. How do you break down tangent squared x? You have tangent x and tangent x. What two numbers multiply to be negative 2 but add to be negative 1? A negative 2 and a positive 1. And there you have it. You factored. Okay? So what we're going to start doing now is we're going to take these ideas, this substituting, this simplifying, this factoring, and we're going to put it all together, and we're going to start doing proofs. So make sure you, eat a good lunch and come in with a nice sharp pencil and a big fat eraser.